Previously, when we looked at recursion, we used it to give us the ability to do iteration. Since that time, we've learned how we can do iteration through loops or through collection methods. We can make things happen many times in lots of different ways in the Scala programming language as well as in other programming languages. So what's special about recursion? Well, it turns out that just simple iteration is kind of the most basic use of recursion, and we can do a lot more than just iteration with it. So we should look at how that works, and we'll start off with some simple examples. So one of the first things that we did with recursion was we made a countdown function that took an int and returned nothing. It was just going to count for us. And we said that if n was greater than 0, that we were going to print out n and then go down to the next number. Countdown of n minus 1. Okay. Let's bring up a REPL here and load that in. And we can call countdown of 5. Now, that was basic iteration. To illustrate part of the way that we can get more power from this, we'll actually copy these lines, and we're going to write another function. It's not called countdown, it's called count up. And other than changing the name, we're only going to make one little difference here. I'm going to take the print and put it after the recursive call. So if we load this back in, and I call count up with 5, as the name implies, it counts up. And that might seem odd to you, because after all, it's calling itself with n minus 1. Clearly, the n value is going down. So why is it that it printed these values in ascending order? And the answer to this is that we have the call stack, that recursion has memory associated with it. And so this is kind of one of the most simple examples of how we can utilize that. To understand this, let's think about that call that we just made. So we called count of 5. And what did count of 5 do? Well, it checks, is 5 greater than 0? The answer is yes. So the first thing inside of there was it made a recursive call to count of 4. Note, the recursive call happens before it printed anything. So count of 5 calls count of 4, but it hasn't done anything else. What the call stack is doing here is it's remembering these things, and this is why I'm kind of drawing all of these, I'm drawing these out. Well, what happens next? Count of the 4 is also greater than 0, so it calls count of 3. Well, 3 is greater than 0, so it calls count of 2. 2 is greater than 0, so it calls count of 1. 1 is greater than 0, so it calls count of 0. Now, nothing has printed yet, okay, because we wind up doing the recursive call in this version. We do the recursive call before we do any of the prints. And the thing about the call stack is remembering where we are in here. So it remembers that we're inside of count up with a value of n that was 5. That's at the top of our call stack. And then we have a 4 and a 3 and a 2 and a 1 and a 0. Now, because the 0 is less than 0, or sorry, is not greater than 0, this winds up just returning back up to there, and nothing happens. But this call was sitting and waiting. It made the call to 0, and then when it comes back to here, it does the next line. And that line winds up printing out the 1. So at this point here, we wind up calling a print line of 1. And after it's printed, it has nothing left to do, so it returns. And it returns back up to the count of 2, which is sitting there and waiting. And after we get there, it prints out the 2. That's the last thing to do, so it returns up to here, which prints out the 3, and that returns up to the version with 4, which prints the 4, and that returns to the version with 5, which finally prints out the 5. So because the call stack was remembering that we went 5, 4, 3, 2, 1, we didn't have to print those things out in that order. We printed them out as we were popping back up the call stack. So as each one of these functions completed and returned, we printed out a value. And therefore they print out in ascending order instead of descending order. So once again, this is a very simple example that shows that there is memory in the call stack. And that allows it to do things that aren't as easy to do with loops. Now, of course, this doesn't do much with it. It just utilizes that memory to print things in the reverse order. We'll come back and we'll see how the stack allows us to do what you could call branching recursion. It's recursive functions that call themselves more than once, and that works simply because the functions, the call stack remembers where you are, and you can go back and basically try other alternatives. And so we'll see that in the coming videos.